Welcome back, folks. Apologies for the slight delay, but we are underway, ready to get underway, rather, with another one of the talks. And this time I am joined by the wonderful Marija Selakovic. She is a developer advocate over at Crate.io. I believe, Marija, you are here to run us through different data properties and how they can affect your solutions. So without further
Yes.
ado, I'll let you get on with the show.
Thank you. Thank you very much for the very nice introduction. Can you please just, okay, awesome. So my slides are there. Thank you everybody for joining today. My topic is going to be about time series data. Actually, I'm going to discuss about challenges for storing and analyzing industrial data and how you can use some of the existing technologies to address these challenges. So before I start, let me give you a few words about myself. I work as a developer advocate at Crate.io. Crate.io is the main developer and maintainer of CrateDB database, which you will definitely learn more about in this talk. My background is in software engineering and data science in general. I also hold a PhD from TU Darmstadt. But my interests lie in the big data, community engagement, and of course, helping developers be successful with CrateDB. So this is going to be a rough agenda for today. First, I'm going to introduce CrateDB as a database and tell you some stuff about it, especially for those of you who are not familiar with the solution. Then I'm going to discuss a bit about industrial time series, what a time series data is at the first place, and what are the challenges for analyzing and storing industrial time series. So what are the properties of these data that make it a little bit more difficult and challenging to efficiently handle them. Finally, I'm going to discuss each challenge into more details. How do they affect actually our storage solution, and finally we are going to finish with a short Q&A. So first of all, what is CrateDB? CrateDB is a distributed open source SQL database for real-time analytics. It's one of the leading databases for large-scale data analytics, and with some properties such as fast querying, aggregations, and ingestion. In general, it combines the best of SQL and NoSQL world. So with the CrateDB, you don't have to learn any new language. You can just use a standard SQL for data query and analysis. It also implements and supports Postgres via protocol that makes it very easy to use CrateDB with many different tools. It also provides you the flexibility of NoSQL database by supporting dynamic objects and schemas. But in CrateDB, you can actually analyze any type of data, including relational data, object data, time series data, geospartial full text data, all in one system. CrateDB is designed with the scalability in mind. It actually supports the horizontal scalability. So you actually just need to add more nodes to achieve more scalable system. And we actually have 3 deployment options: cloud, hybrid, and on-premises. Performance is very important. It's always a moving target. So the queries must be fast, and they are fast in CrateDB. We also support columnar storage for column-based data retrieval, which allows you to do very fast aggregation, sorting, and grouping. And we can also see CrateDB as a kind of a search engine. It's built on top of Apache Lucene and offers you many nice properties of Apache Lucene actually for full text search, for example. So as I already mentioned, there are 3 kinds of deployments, or like 3 kinds of services that we offer with the CrateDB. The first one being CrateDB Cloud, which is available on all major hyperscalers, Google Cloud, AWS, and Azure, and it's hosted and managed by Crate.io engineers. You get a full, of course, you get a full set of CrateDB features, but you also get fully automated backup and recovery, easy scalability, and quick start. In case you don't want to use our cloud solution, you can also deploy CrateDB on the Kubernetes cluster on your own cloud region, and we recently actually made available our Kubernetes operator and Apache license 2.0. And last but not least, CrateDB has been open sourced since a long time ago under Apache license 2.0, so you can also run it on your own on any infrastructure that you wish. So topic for today is going to be industrial time series data. And before actually going into more details, let's all align on what time series data is. Simply speaking, time series data is a data that describes how certain metric changes over time. And it's usually associated with the timestamp. Every record in time series database is associated with a timestamp. This is a moment in time which the value is collected. And why today I chose to talk about time series data, it's because of its growing importance and variety of applications we can see, starting from manufacturing, financial markets, energy, cybersecurity, monitoring, streaming, etc. So time series data as a format has found its way in many interesting applications nowadays. And this is just some example how time series data is actually stored in CrateDB. I would like to emphasize at this moment that CrateDB allows you to freely define your data model. This is very important. So for example, in this case, we have, of course, a timestamp that is associated with some metric values like battery, CPU, or memory. But I, for example, decided here to choose the values for the battery in a single column. I could also choose to create a column for every of these metrics. For example, for a battery, I could have 3 different columns from CPU as well and memory too. But in this way, I choose to actually store these metrics in a single column, and CrateDB allows me to actually freely define my data model. So this is kind of important. So an industrial time series data, as we could all imagine, is becoming, already actually became increasingly important in the manufacturing industry. What is characteristics of the industrial time series data? First of all, we are usually talking about huge amounts of data that we need to collect and process every single day. But we are also talking about different data formats. So the number of machines and signals and sensors we use in manufacturing process is very varied. So like type of data we are collecting can come in various formats, and we need comprehensive solution actually to be able to store all these different formats. We also see different data frequencies need to be considered when choosing a database solution. So very often we need to combine high frequency and low frequency data. And this data actually provide a very huge potential for valuable insights if we have the right technology. When talking about the right technology, I'm now going to discuss what do we have for analyzing and storing time series data. Of course, there are probably way more solutions, but some of the most common ones that we have seen. First, we could actually store time series data in a relational database. It has certain advantages over other solutions, such as SQL accessibility. SQL is, in my experience, a very important language to support because developers are familiar with it. There is no steep learning curve, and you can start using database right away. Then relational databases usually come with a high data availability, which is quite important, easy integration. However, with the amount of data we usually store from manufacturing processes, it's difficult to scale. And with the high data volumes, we often see performance degradations. The next solution that we can consider is NoSQL databases, which actually overcome the scalability, flexibility, distributions challenges. But these databases are generally more complex and expensive to deal with, and integration is not always straightforward and out of the box. Recently, we have seen a rise of different time series databases that are actually built for time series data. We also can see that many of these databases do not support, or they have very, very slow performance when it comes to complex data analysis, such as aggregations. And very often, because of the strict data model they enforce, you have a need for another database to store data that are not in a time series format. Talking about time series, we can conclude that not all time series are equal. Use cases vary significantly, and also not all time series solutions that we find on the market these days are made equal for industrial time series data. So in our experience, in dealing with different time series, industrial time series data, we actually observed 3 challenges that are pretty much common for every use case, and that needs to be considered when choosing the good solution for your use case. First one being availability. Second one being semi-structured data. So data coming from industrial processes are sometimes completely unstructured, but very often they have certain structures that you would like to keep. And we also need to take into account different data frequencies, meaning we need to handle data from different machines that come with different frequencies. So let's move to the availability topic. So it's not really, I don't really need to convince you that availability is important in manufacturing process, because it needs to keep working 24/7, of course, and having highly available system is super crucial for, first of all, keep production running, then being able to do some real-time data analysis, and also ensuring that your production process is running with a high performance and superior quality. So availability is a very significant concern and requirement when it comes to storing and analyzing industrial time series data. So let's see how CreateDB actually addresses availability requirement. So CreateDB is, first of all, a distributed system that is built as a shared netting system. So it has a built-in shared netting architecture. So what does that mean? It means that every node in a system is considered equal and can take over any task. So there are no hierarchies in this node, and there are no different preferences when considering the nodes in the system. So this is super important for making scaling much easier. Also, there is no single point of failure if the node actually crashes. Of course, it can temporarily affect the performance, but in general, since there are no hierarchies, there is no master node or any centralized node, the effect is less severe than in case where you don't have such infrastructure. And also data that are usually split into shards are automatically balanced across all nodes in the system. So this process explains how the high availability is ensured in this type of architecture. So imagine the situation that the node leaves because of some hardware failure, for example. Then what CreateDB does, the first step it does automatic failover. So which means that all the data that are lost become available on the remaining nodes. We can see temporary reduction of performance until the new node joins and automatic synchronization rebalancing takes place. Finally, once the new node becomes the part of the system, the self-healing process takes place in which data are fully replicated again. So automatic failover is a crucial step for securing high availability, and this is actually done through built-in replication. So what does it mean? For every shard that you create, so let's say you create a table that can be clustered into more shards, so the table is actually splitted into different shards. For each of the shard, you have a full control over how many replicas you would like to have for this shard. And even if you do not explicitly specify how many replicas you need and you would like to have, the CrateDB as a system creates at least one replica for a shard. So the shard replication is a built-in property of CrateDB, which actually makes sure that if the replica shard can take over any primary shards in the case when primary shard become unavailable. So imagine that the node where primary shard is located leaves, the replica can take over the role of the primary shard and the data are again fully available. So another aspect of CrateDB that enables high availability is called logical replication. We call it rather a feature because this is something that a CrateDB user can actually choose to do. And with the logical replication allows you to replicate the tables from one cluster to another cluster. It follows a publish-subscribe model, where publisher is a cluster that makes data available to other clusters, and subscriber is a cluster that receives replicated data from one or more publishers. And not only data are replicated, but also all operations on this data replicated so that you have always the fresh set of data on the subscriber clusters. And every cluster in your system, again, is considered equal. So can have both publications and subscriptions as well. And on subscribers cluster, the data that are replicated are read-only. One interesting use case that is kind of also important from the availability point of view is improving data locality. So imagine we have a situation where you have one central reporting cluster and we would like to make data closer to the user, so we can replicate the data that concern every region to the cluster lying in this region. And in this case, user actually have lower latency when accessing this data and higher availability because it doesn't need to query data all the way to the central reporting cluster. So to sum up, built-in replication on the shard level and the logical replication as a feature is something that really allows CrateDB to achieve high availability, which is very important in this industrial setting. And the next topic is, the next challenge I would like to discuss is about semi-structured data. So in these industrial processes, we can actually very often see the case where machines are very complex and they are consisting of different submodules. So, and even these submodules can consist of another module. So like usually when we collect data from a single machine and from each of these submodules, maybe we would like to keep some sort of relationship between this data. We would like to know what type of data are coming from each module and how do they relate with the data coming from that machine in general. So we see that the structures in data are naturally creating, sometimes involving multiple time series. So what do we want in this case for better analysis and maybe easier analysis? We have seen that usually it's advisable to keep this structure in the data and to still have these properties of fast and easy search and fast aggregations when it comes to semi-structured data. So this is something that you can easily achieve with the CrateDB, and one of the features, one of the examples that we consider here are so-called hierarchical structures. So imagine that we have a machine with device ID and the data that are collected from different sensors in this machine. So we can already see that there are some hierarchies in this data, that value of this data, for example, can be somehow correlated or actually connected with the device ID from the machine we are collecting the data and with the timestamp. So many time series solutions, database solutions require you to flatten the data, and they have very strict data models for storing time series data. In CreateDB, actually, we allow you to keep these structures, and the feature that allows you to do this is called document store, which means that you can store the data in a relational format and as JSON-like documents at the same time. So what we have seen at the very beginning, the data looked like a relational database, but how they are stored into columns, there is definitely more flexibility there. So you can store the data like JSON documents. So we can see a very simple example where we have a data declared as object, meaning it's going to be stored as a JSON document, and it has two properties. Of course, the number of properties and nesting levels you may have in the object is totally up to you. It's maybe not advisable to have, I don't know, arbitrary number of nesting levels, but still there is a flexibility to choose what you actually need. And except storing data in the object format, you can also have a full control over schema of these objects. So CreateDB support dynamic schemas, which gives you the highest possible flexibility and which allows you to add new columns in the object, actually to add new attributes. So you could have, for example, stored in one column objects with a different set of attributes. But if you really want your schema to be strictly followed, you can declare this object as a strict. And then it means that every object that is stored in this column need to follow the column definition. Finally, there is another way of declaring object called ignored, which shares the same properties as the dynamic objects, but the difference comes from the indexing perspective. So if you add new columns, they get ignored from the system and they are not being indexed, which is also a very important topic to discuss when it comes to semi-structured data. Finally, querying semi-structured document is very easy. You can use pure SQL as you've learned to use it. So you can extract the top level columns, or you can extract the nested fields. For example, you can extract sensor data or event data from the data object using pure SQL and in a straightforward way. So I already mentioned indexing. It's very important for enabling fast queries and column-based data retrieval in CreateDB because it uses Lucene as a storage engine. And Lucene has a very unique indexing strategy. It's one of the probably most famous search engines these days. It's very old, but still embedded in so many systems that it doesn't make sense to build a new one. So Lucene actually uses different data structures for different type of values that you would like to store. It uses inverted index for text values and block KDD trees for numerical values. I will briefly mention inverted index later on. And also CreateDB supports doc values, which is a name for column-based data storage that is built for effective sorting and aggregations, and they are enabled per default. So like doc values are, again, something that you as a user can disable, currently only for the text fields. And of course, indexing can also be disabled by the user in case you are pretty sure you don't need to index certain columns. So inverted index, how does it work? It actually maps the content of the location to the document ID in the database. So, and there are two types of inverted indexes that CreditB supports, plain and full text index. The difference is the plain index uses the full value of the column for mapping, and the full text index actually does some sort of analysis on these values. So it does some sort of tokenization, and how you actually want to tokenize the fields for mapping, it's totally up to you. So like also CreditB from this point of view offers a lot of flexibility. So in this case, we, for example, tokenize based on the words by using the space character, and ended up with the 4 full text indexes. So for example, now if I want to search all the rows where sensor, for example, is contained in the value of the model column, I can very easily extract all the rows without going into each of the row in the table and checking whether the condition holds. The next important indexing strategy for CreditB is, as I mentioned, doc values. So inverted indexes is a very good solution for searching documents by terms, but not when you need a column-oriented retrieval of data. So in time series use cases, and especially industrial use cases, we have seen a lot of need for doing aggregations, sorting and grouping. And to be able to do this, CreditB allows column-based data storage, which actually maps the document ID to the value of each individual column. So next time when you need, for example, to calculate the average of the quantity in this case, you just need to extract doc value for the quantity column, and then you can do much faster search than actually going through every single row and extracting the value of the quantity column. So the final topic for today, when it comes to the challenges that we observed in many use cases, is the data frequency. And frequencies is important property of the time series data need to be considered. Usually defines the number of time the data is sent in a given interval, and in industrial settings we can actually see a lot of data that really have that come with in different frequencies. So we have machines and sensors, for example, that send only hundreds of signals per second versus those that send hundreds of thousands signals per second. And in many cases, if not all cases that we have seen up to now, needs to be combined with the business data, with some sort of static data. So the one way that these data can be stored is actually storing one record per measurement, and many times series databases actually require you to define data model that stores one record per measurement. Of course, it can bring a huge overhead, but usually you would need to use a different, for example, database for storing non-time series data. So the question is always, is one database enough, or do I need to consider more solutions? In CreditB, actually, we can say you can use only CreditB for storing all data, and you don't need to actually store one record per measurement. You can actually use a feature called arrays. Arrays very known term in database world, which allows you to store data in arrays of primitive types or even objects. That's also supported. And for example, what you can do, you can also store several measurements in a single row in order to save on a disk space in general. To use arrays is straightforward. You just need to declare the column as array. And also the extracting values from arrays is also relatively easy. So you need just to use the known syntax for fetching data from arrays, or like slicing data as well in an SQL format. So like it's relatively handy feature that we have seen many times used in case when you have a lot of measurements coming in a certain period of time. Another interesting feature that actually enables you to keep all data in a single database is joins. Implementing joins in distributed settings is not an easy task, but it's supported in CradyB and works quite well. So, for example, imagine that we have some static information about different devices in our plant, and for each of these devices, we would like to keep data such as ID, manufacturer, model, and version. And then we have another table where we actually store the measurements, the exact measurements, and we may actually get thousands of records per second, for example. So sometimes there is a real need and the use case when we need to combine these two data, and joins actually enable you to do this in CradyB. So for example, consider the simple query in which we want to find all sensor data for certain machine. What we need to do, we need to use a plain syntax, SQL syntax that we are familiar with, and to join two tables on a device ID column, and to use where clause actually to extract, to actually put a condition for this particular machine we are interested in. So CradyB supports all types of joins, including cross joins, inner joins, and outer joins. As I already mentioned, joins are kind of tricky to implement in distributed settings, and it's always a moving target for us when it comes to the performance of joins. Currently, we use two algorithms for implementing it. First being nested loop, and it's considered relatively slow in general because it has quadratic complexity, but we have many optimizations of this algorithm for distributed execution. And we also have distributed hash join algorithm for some special kind of joins where this algorithm works quite well. And if you would like to learn more about how joins actually work in CradyB, I put a link to our FOSDEM talk from this year on distributed join algorithms in CradyB. So it's a great feature. It should not be overused, and it's always a moving target for us because it's very important for many use cases. And the final feature I would like to discuss that is always very interesting for any analytical tasks is user-defined functions. So CradyB supports many analytical built-in functions for manipulating objects and arrays in general, strings, numbers, and other data types. But you as a user can actually choose how you want to deal with the data by creating your own functions. And currently, CradyB supports function declarations in JavaScript language. This may change in the future. We may support more languages, but this, for example, a simple function shows you how you can implement a filter function on arrays, which is sometimes a very handy function to use if you have a lot of measurements stored in a single array and you would like to filter them based on certain conditions. So like user-defined functions in addition to joins is actually what allows you to keep all the data that you need in a single database, not only industrial data but also business data, and you can use them and combine them together. So with this in mind, we can say that the CradyB is a great database solution for many actually use cases, such as time series data, Internet of Things, in case you need fast queries and aggregations, full text search. When you need SQL as a query language, it's very important. We have seen with many of our clients and users that they really appreciate SQL support because they don't need to learn any new language to use our database, geospatial data, logical replication where you need hybrid deployments on our own cloud or your own private cloud region, and when you need high availability and scalability. However, there are some use cases that are not a good fit for CrateDB, and I think it's important also to discuss here these use cases as well. First of all, CrateDB does not support transactions. So if you have transactional workloads, these are not good candidates for CrateDB. If you have highly hierarchical normalized data models, this will probably not work very well in CrateDB, even though CrateDB helps you to store hierarchical data and semi-structured data in general. But for highly hierarchical models, you would probably need to query these models. You probably need a lot of joins and a lot of conditions, which in distributed settings could be quite slow. And also CrateDB does not support foreign keys. So I hope that this topic was interesting for you today. There is definitely a huge interest on time series data that come with the high volumes, and the high volumes means we can do a lot of interesting data analysis. We observed some challenges that are kind of occurring for every industrial use case that need to be taken seriously into account. And these are availability, different data formats, especially semi-structured data, and different data frequencies. And I actually, in today's presentation, I explained the set of features that CrateDB offers for handling time series data in general, including industrial time series data. And I would also like to invite you to try out our CrateDB Cloud. You can start it very easily, and when you start it, you get $200 free credits that you can use towards different hardware configurations and different database operations. So, in case you would like to make a contact with us, don't be afraid to contact me over email. You can also join our community or contribute to our GitHub account, to our GitHub repository. The CrateDB is open source project, so everybody is welcome. And of course, if you like it, give us a star. So that is all from me for today. Thank you pretty much for your attention, and I'm looking forward to your questions.
Thanks, Marija. Really informative. And I'm sure we're going to have some interesting questions. Seeing a bunch come through right now, so we'll jump right into them. First off, we've got one from Mirko. Mirko asks, how does CrateDB compare to, I think it means CrateDB, compared to Apache Druid, and what are the major differences between the two?
So I'm not really a big expert on Apache Druid. So CrateDB is, first of all, the database that offers. It's a distributed database built on Apache Lucene, following the similar strategy for indexing and storage, and also offering on top of this SQL. So I would say these are some of the unique properties when it comes to the CrateDB.
Okay, and I see a question coming in from Gurk. Can Crate document words? Can CrateDB documents handle XML like JSON and the sorts, or does it need to be translated?
This is a very good question that we are also exploring these days. To be on a safe side now, I would say also it needs to be translated first, but we may come with some very interesting content around storing and handling XML data.
Okay. And Mirko asks, what was the reason for choosing the JSON format instead of maybe more performance positive open formats with better read and write speeds, such as Parquet and Avro?
I would say I mean, probably there could be even better answer than the one that I'm going to provide today. But I think JSON was super popular at the time the CreateDB was created. It also gives you a lot of flexibility, and that was probably one of the main reasons. But interesting questions, so I will bring it back to the team and see what they have to say.
Okay. And I think the final question we had was from Reza. Reza asks, for a newly ingested data, how much time does it take for it to become available for querying? Does it depend on data and column types, or is there a kind of generic time frame before you can access that data?
I think it becomes available almost instantly.
Okay, that's good then. I think that was all the questions we had. But it seems you said you want to have a little bit back and forth with the team. I'm sure you're available to be reached out to, right? If people have
Absolutely,
any queries.
yes. Please be free, use this email, reach out to me in case you have any other questions. We can discuss it in more informal settings. Yeah.
Fantastic. Well, you've been a pleasure. You've been a treat, Maria. I'm going to let you go now. I'm going to
Thank
let
you.
everyone go grab some food. That's right. We've got about an hour break. When we return, we'll move into our next talk. So make sure you get your stomach full, get sat down, because we've still got more presentations on day number 1.
Thank you very much for having me today.
Thank you.